Welcome to part 3 in my video series on configuring a 7-segment display using I2C and a MCP23008 integrated chip. In the past 2 videos, we have seen how to install and access the I2C interface from a Raspberry Pi and how to produce output on the MCP23008 by turning the GPIO pins on or off, producing an output. The next key step is to get our 7-segment display showing some digits. Despite its name, the 7-segment display has 8 inputs, due to the 7 segments used to display the digit itself, plus one additional one for the decimal point. The segments are typically assigned a set of letters, which correspond to the pins that control the input. These start with the letter A at the top of the digit, and rotate clockwise, finishing with the central horizontal segment. To discover which segment corresponds to which control pin, we should consult the manufacturer's specifications. The display I am using has a code of FND500, which has 5 pins at the top and 5 pins at the bottom. The pins are numbered 1 through 10, from the bottom left of the display in a counterclockwise manner. 4 pins on each end are connected to the segment controls. For this display, they are as follows. The 2 center pins on each end are either a common cathode connection or a common anode connection, depending on which model of the display you get. The FND500 is a common cathode model, which means that the pins 3 and 8 are both connected to ground, or the negative terminal. The FND507 would provide a common anode connection, meaning that these 2 pins would be connected to the power supply, or positive terminal, and the segments therefore connected to ground. As I am using the MCP23008 to power my segments directly, I have chosen to use the common cathode option here, so that when a pin is turned on, the corresponding display segment is also activated. This is how I have completed the wiring of my 7-segment display. Each of the lettered segments increments to match the GPIO pins on the chip, so that segment A is controlled by GP0, B by GP1, and so on, leaving the decimal point for last at GP7. Note also that the ground rails for my display are isolated by a single 270 ohm resistor, which links back to the other breadboard where the chip and the Pi are connected. I have used a 1 watt resistor for this purpose. The next step is to determine what byte commands need to be sent to the chip to enable the display to show some relevant output. For example, to create the number 0, we need to turn on segments A, B, C, D, E, and F. For the number 1, we only need segments B and C. To do this, we'll create a truth table. This will enable a quick lookup against the expected output and the required input. As we've connected A to GP0, I'm going to invert the sequence of letters so that it is easier to identify the bits that we require. Let's start with the easy one, which is all pins off. This, of course, will be all zeros. The next one is the number 0, which, as we said before, requires all pins except for the decimal point and segment G. Now let's complete the rest of the table. The next step is, of course, to test our code and see whether or not we have managed to plug it all in correctly and choose the correct hexadecimal values for our chip outputs. The first command we're going to run is, of course, to set our I/O register direction to be all outputs for the 8 pins. This is done by sending the bytecode 0x00. From here, we can run a few tests by addressing our GPIO pins on the register 0x09 with any value we like. But for testing purposes, let's use some of the values from our table. I'm going to test by turning everything on first, using FF. This will help ensure that everything is connected as expected and that I don't have any issues with my circuit. I will then proceed to test digits 4 and 7 and then turn everything off again. In much the same way that we tested the chip with an LED, we're now going to write a small script that will enable us to control the 7-segment display through code. You will see that there is a new variable defined, which is a dictionary. This enables us to specify a string or an integer and output the corresponding hexadecimal value. The second section of code provides us the ability to test all segments by flashing them on and off 3 times, and then should use our defined dictionary to display the numbers 0 through 9 incrementally for half a second each. Thank you for watching. In my 4th and final video in this series, I will demonstrate chaining multiple MCP23008 chips together and using the I2C interface to address these separately.